Welcome to AI Frontiers. Today we are unraveling the latest breakthroughs in language understanding and generation. In this episode, we spotlight 31 new research papers in computational linguistics, all published within a single action-packed day, December 27th, 2025, on the arXiv preprint server. Get ready to discover major themes, technical advances, and deep dives into 3 field-shaping studies as we journey to the very heart of computational linguistics. Here is what you will learn in today's episode. We will unpack the field of computational linguistics and examine its real-world impacts. We will explore 4 key research themes currently shaping the discipline, connect critical findings to practical advances, and spotlight 3 influential papers published on this pivotal day. Finally, we will look ahead to glimpse future challenges, opportunities, and emerging ethical frontiers in language AI. Computational linguistics, often abbreviated as cs.CL, is dedicated to teaching computers how to understand and generate human language. This field sits at the intersection of linguistics, artificial intelligence, and computer engineering. Advances in computational linguistics power search engines, machine translation, and automatic summarization, among many other applications. Researchers in this area must grapple with the complexity of language, including context, emotion, ambiguity, and cultural nuance. These efforts drive greater inclusivity and accessibility in technology worldwide, making digital tools more attuned to the richness of human communication. The first major theme is efficiency and optimization in language models. Researchers are intensely focused on making models not only smarter, but also faster and more resource efficient. For example, the prompt choreography framework introduced by Bai and colleagues halves the response times of large language models. Width pruning strategies applied to models such as Llama 3.2 enable the reduction of model size while preserving robust reasoning capabilities. Dynamic attention routing further boosts computational efficiency without sacrificing accuracy. These innovations pave the way for real-time, scalable NLP applications accessible to a broad spectrum of users. The second theme centers on faithfulness, explainability, and evaluation. The research community is prioritizing the development of AI systems that provide truthful, not merely plausible explanations. Lightweight hallucination detection frameworks such as HEMM drastically speed up the process of fact-checking AI outputs. Newly developed metrics probe the reliability of step-by-step reasoning, offering deeper insights into model trustworthiness. Notably, some models, as demonstrated in work by Wang et al., maintain faithful reasoning even without explicit verbal hints. Collectively, these advances lay the groundwork for transparent and responsible AI, particularly in sensitive application domains. The third theme is multimodal and domain-specific modeling, marking a significant expansion of language AI beyond text. Modern models now align linguistic inputs with sensor data, images, and other modalities, as evidenced in the work by Xu and colleagues. The Lens system synthesizes health narratives from wearable devices, offering actionable insights for clinical use. Meanwhile, TabiBert, presented by Turker et al., revolutionizes natural language processing for Turkish, a language characterized by rich morphology and historically underrepresented in NLP. These multimodal models unlock new healthcare and accessibility applications, empowering marginalized languages and specialized domains. Theme 4 highlights new benchmarking, ethical and social impact frameworks. Cutting-edge benchmarks now target areas such as code generation, sentiment analysis, and clinical note segmentation. Tools like CNSite evaluate the structuring of clinical notes, which is vital for patient care and downstream analysis. The GHA-LID framework advances hope speech detection in low-resource languages, leveraging transformer-based multilingual models. Ethical considerations are front and center, with active efforts to address bias, misinformation, and fairness. The growing societal impact of these advances is evident in domains such as news, mental health, and beyond. Let us now examine the key findings from these 31 papers that are pushing the boundaries of language AI. First, TabiBERT, developed by Türker and colleagues, establishes new standards for Turkish natural language processing through large-scale, innovative architecture. Second, the prompt choreography approach by Bai et al. Doubles the speed of language model workflows, markedly improving responsiveness and scalability. Third, the LLMs system from Xiao et al. Aligns sensor data with large language models, generating actionable, clinically validated mental health narratives. Fourth, the HHEM framework makes hallucination detection both fast and scalable. Finally, the all-or-here attention mechanism demonstrates that efficient attention can be achieved without compromising accuracy, pointing toward more sustainable AI. How are these advances achieved? The core methodologies driving progress include transformer architectures, which function as orchestras of attention to ensure context-aware AI. Innovations such as rotary positional embeddings and flash attention enhance memory management and computational speed. Prompt engineering is used to strategically nudge models toward desired workflows, while structured pruning trims excess parameters for leaner, more efficient models. Rigorous benchmarking, supported by domain-specific metrics, guides the continuous refinement and assessment of these technologies. Our first paper spotlight is TabiBERT, introduced by Türker and colleagues. This large-scale modern BERT foundation model addresses the long-standing natural language processing gap for Turkish, a language notable for its rich morphology and historical underrepresentation. TabiBERT is trained on a corpus of 1 trillion tokens and features an extended context window of 8,192 tokens. It leverages rotary positional embeddings and flash attention for heightened efficiency. The model outperforms all prior Turkish language models across 28 benchmark tasks and is fully open-sourced, providing a blueprint for the development of advanced models in other languages. The next highlight is prompt choreography, presented by Bai et al. This work addresses workflow bottlenecks in multi-agent systems powered by large language models. By introducing a dynamic, global cache, prompt choreography enables parallel and efficient processing of contextual information. The model is carefully fine-tuned to ensure cache-faithful outputs, maintaining accuracy while maximizing efficiency. As a result, response times are improved by a factor of 2 to 6, making the approach highly scalable for real-world applications. This innovation empowers the development of more complex and interactive AI systems. The third featured paper is LLMs, developed by Xu and collaborators. LLMs aligns raw sensor data with language models to generate clinically actionable narratives for mental health support. The system processes over 100,000 question-answer pairs from 258 participants, utilizing a catch-level encoder to map sensor streams into the same representational space as text. LLMs is clinically validated, outperforming strong baseline methods in a user study involving mental health professionals. This work represents a significant step towards scalable and personalized AI-assisted mental health care. Looking ahead, several research directions are emerging in the field of language AI. Modular and compositional architectures are facilitating flexible, integrated reasoning across multiple modalities. There is growing emphasis on self-correcting and self-explaining systems to enhance trustworthiness. Efforts to democratize access are extending advanced language technologies to low-resource languages and specialized domains. Human-in-the-loop approaches are gaining traction, promoting seamless collaboration between AI systems and domain experts. At the same time, persistent challenges such as generalization, faithful reasoning, and ethical considerations continue to drive innovation and vigilance. This synthesis was created using a combination of advanced AI and human expertise. The research narrative and summary were generated with GPT 4.1, while text-to-speech synthesis utilized OpenAI tools, and images were provided via Grok. All outputs underwent review by human experts to ensure accuracy and clarity, though some oversights may persist. Full references are provided for transparency. This collaborative process at the frontier of knowledge sharing exemplifies the synergy between artificial intelligence and human insight. Stay ahead by subscribing to the AI Frontiers YouTube channel, where weekly deep dives cover the latest AI research. Join a growing community of curious minds. Leave your comments, share your questions, and help shape future episodes. Thank you for exploring the language frontier with us. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.